Hello Physical Science. We're going to wrap up Chapter 2 today. I'm talking about chemical properties still. So if you remember, we talked about the last two the first two chemical properties being flammability and reactivity. So we're going to continue on with that, and we're actually going to talk about more about how we can actually tell that a chemical change has occurred. So how can we look at what observations can we make that tell us a chemical change has occurred? And there's three common types of evidence, so I'd write these down. We're going to hit them all here in a second anyway. We have change in color is one way we can tell a chemical change has occurred. The production of a gas is another. And the formation of what is called a precipitate. So that is going to be maybe a new word for you that you haven't heard before. So all three of those things are going to be evidence for us that a chemical change has occurred. So first one is a color change. So our example they give us is a color change in a banana peel, and it is caused by chemical changes that are taking place inside the cells of the banana. So a chemical change occurs again when the substance reacts and forms one or more new substances. So here we have an example. Again, this is a banana. It might not be ready to eat yet, but as it ripens over time, chemicals are actually produced inside the cells. Different hormones actually are what they are called that are responsible for the process of ripening. Again, that's a banana. When it gets that yellow color, that's probably when they're best to eat. And then if it keeps going, more chemicals are released, and then they will have that brownish color. So that is, again, one example of a chemical change. Again, is a change in color. And we have another example of a change in color. Again, it could be a clue that has produced at least one new substance. Again, same thing that we just mentioned, but we're going to get another example. There's multiple examples here. A shiny silver bracelet that is exposed to air will darken, so that is a color change that shows that a chemical change has occurred. As a match burns, it shrivels up and turns black. Another color change that shows that a chemical change has occurred. And a new copper roof and an old copper roof have different colors. So we're actually going to see that right here. So a new copper roof has a reddish color to it. However, over time, they turn that greenish color. So if you look over here, right here on the right, this is actually a copper roof as well, and they called this color change patina. That's the fact that it has changed that color. On an old copper roof is a mixture of copper compounds. So over time, being exposed to the oxygen, new copper compounds have formed. Again, things have binded to this copper to cause this green color, which is an example of a color change. So that's our first way. Color change is how we can recognize a chemical change. Our next one would be the production of a gas. So when you mix vinegar with baking soda, bubbles of carbon dioxide form immediately. A similar chemical change happens when you use baking powder as an ingredient in a cake recipe. The bubbles of carbon dioxide expand and they cause the cake to rise. So it produces a gas, again, the CO2, and that is kind of an indication that, it is an indication that a chemical change has occurred. So that's a pretty simple one. If you mix two things together, the formation of bubbles is almost always associated with the formation of a gas. So that is, again, our second way, the production of a gas. And our last one is the formation of a precipitate. So this might be a new word for you. So any solid that forms and separates from a liquid mixture is called a precipitate. So it's basically when you mix two liquids together and a solid is formed, then we call that a precipitate. So our example is when an acid is added to milk. Again, both of those are liquids, acid and milk, both liquids. Proteins in the milk undergo a chemical change that causes them to stick together in clumps and form a precipitate, which is again solid, and our example here is cottage cheese. So our example again of a precipitate is when you mix two liquids together, a liquid mixture, and then a solid is formed from those two liquids. That is our example of a precipitate. Definitely make sure you jot this down. And again, that is another way that we can tell that a chemical change has occurred. So to wrap this chapter up, we're just going to one last time, we're going to hit on the difference between chemical and physical changes. So that's what we've been talking about for our last two sections here. So how we can tell, again, we can ask ourselves that one big question here when we can tell the difference: are different substances present after a change takes place? If not, then a change is physical, not chemical. So if the composition of the materials are different at the end compared to what we started with, that is one way that we can tell that a chemical change has occurred. If the substances are the same, then it's a physical. Substances are different, it's chemical. So when matter, and again, this is just another way to word it right here, so this is important. When matter undergoes a chemical change, the composition of the matter changes. So that's how we can tell that a chemical change has occurred. The composition of the matter has changed. When matter undergoes a physical change, the composition of the matter remains the same. So again, if I have a piece of paper, I just crumple it up. Again, it looks different. It might have a different density. It might have some different physical properties, but it is in fact the exact same paper on a chemical level. It has the exact same composition. However, if I take that piece of paper and I light it on fire, the composition of the matter is definitely going to change. It's not going to be the same paper anymore. The oxygen reacting with the flame, and again the burning, it's going to leave an ash that's going to be a completely different composition than what we started with. So that is pretty much the easiest way to tell the difference between a chemical and a physical change. And to wrap it up, we just mentioned, again, this is kind of maybe a little bit of a exception to the rule, that even if you observe a color change, a gas, or a precipitate, we cannot be 100% sure that a chemical change has taken place. So those are our examples. They are the most common. However, there are always exceptions to rules. Well, mostly there's exception to the rules. And one example that they give is that when an iron horseshoe is heated, its color changes from gray to red. However, the iron is still iron. It did not change. That means that the change has been physical, not chemical. So for the most part, those three characteristics that we went over up here, color change, gas, or the formation of a precipitate, are usually, again, most of the time, indicators of a chemical change, but you cannot rely on that 100% because, again, right here, a color change has occurred from gray to red, but the iron is still iron. It has just been heated up. So you still got to be a little bit careful to make sure that you, again, don't just make an assumption right away. You have to actually maybe do an investigation to the composition of the material. So that is it for Chapter 2. Let me know if you have any questions.